All right, hey guys. So we're on lesson 3 of dealing with functions again. This is the last lesson. This will be for Friday and Monday. After that, we'll do a review on Tuesday and Wednesday, and then Thursday and Friday we'll test on this. And then we're pretty much done with this unit. Only one more after this. School's almost over, guys. Okay, so again, we're composing functions here, and this is a strange lesson. You might immediately get confused. I'm going to try to kind of go a little slower on this one because it is a strange concept. It's a little bit, sorry, I froze. Hold on one sec. Okay, there we go. Oh, there we go. Okay, cool. So autofocus. Okay, we're in high def. Okay. Sorry if the screen is a little blurry, guys. Okay, so basically, this lesson boils down to a function within a function. So you're going to see something like this. I always do that. So basically, it's the function of x, but within that function, we have the function of g. You might also see it look like this. So those are two different ways to see functions within functions. The one in the middle is what you substitute in. So basically, whatever g is, that is what you would input into the function for f. You'll see this when I go over the first example. All right, so let's do this. So in a composition, one function is composed of another, meaning that it's substituted is a good word here, into another function to create a whole new function. And that function might be kind of like a combination of two real world scenarios. Sorry. So like I just wrote on the previous sheet, it'll look like this, or it'll look like this. So basically, if I have the function of g, the function of f is going to go within that function. Here, same thing. It's kind of like sandwiched. The one that's right in the middle is the one that we're going to substitute in. And I kind of showed that right here, right? Think of it like a sandwich. So first example. So, man, I really hope you guys can see this, okay? So f of x is 7x minus 2. And then g of x is just 2x. I'll write that over here just in case. F of x equals 7x minus 2, and g of x equals 2x. So it wants us to find f of g of x. So basically, we're going to take g, which is this guy right here, and we're going to input it into f. Now notice, they're both x, right? And there's an x in each one of these. So basically, whatever this guy is right here, we're going to insert him right here into that x. So if you can see here, I color-coded it. So 7x minus 2 was my f, right? 7x minus 2. And then my g of x is just 2x. So I'm going to take that 2x and replace my x. Originally it was just an x. And I'm going to replace it with whatever g is. So it goes right there. And what this does is this creates a new function that we need to simplify. So, if we just multiply here, 7 times 2 is 14. The x just goes along with it, and it's minus 2. So that's how to do the basic function within a function. Now, this example number 2 right here, let me see if I can. Okay, I think you can see a little bit better. So we have two functions, f of x and g of x. I made f of x purple and g of x pink. And we're going to do two different things. Here, it's f of g of x, f of g of x. And over here, it's g of f of x. So we're going to do one way and then the other, depending on what it's asking for. So here we're inputting g into f, and here we're inputting f into g. So you will get slightly different answers because of that. Don't assume that you're going to get the same answers for each. So originally, f of x was 3x plus 4, 3x plus 4. My g of x is 8x minus 3. So that's why that goes inside of the x right there. It's like substituting, right? It's inputting that number or that function within another function. Then we just distribute. We have a monomial and a binomial. So it's 3 times 8x, which is 24x, and 8 times negative 3, which is negative 9. This plus 4 just drops down, and we combine our like terms, which are these guys right here. And negative 9 plus 4 is negative 5. So my answer, when I input g of x into f of x, is 24x minus 5. Now let's do the opposite over here. Here we're going to insert f into g. So my original for g is 8x minus 3. My f is 3x plus 4, which is why it goes right here. And then we're just going to distribute like we did before. 8 times 3x is 24x. 8 times 4 is 32. And then minus 3 just tags along there. I combine my like terms here, and I get 24x plus 29. All right, so this one is a little bit more real world scenario. This is where it's going to want you to like make the function itself. It's not going to give it to you, but it's going to give you all the information you need. So here it says that a lady works at a cosmetic store. It says she receives a weekly salary of $350. And then she's paid 3% commission. So basically, if sales are, well, let me finish explaining. So she's paid a 3% commission, basically extra, on sales that are over $1,500. So what that basically means is if the store does well enough, the workers that are working there might get a bonus. So that's the idea here. This kind of example is good if you are trying to plan for your finances, figuring out how much money you could possibly make, if you're trying to buy a car or something. So this first part right here says, let x represent weekly sales. And we're going to write a function, f of x, to represent her weekly sales over $1,500. So if we want to know sales that are over $1,500, that's basically asking for the difference. And when we're talking about the word difference, we're talking about a subtraction problem. So that's why we're going to take whatever our sales are, which is what x is, and we're going to subtract 1,500. If sales were 3,000, the store in a week sold $3,000, which probably isn't that much. If we wanted to see how far over 1,500 that is, we just subtract it, right? So they're $1,500 over. Now, once you find that, then we deal with that 3%. Now, just in case, we need a little memory check here. 3%, when we do that, to turn it into a decimal, we take where the decimal place is currently and we move it twice. So 3% is 0.03. So again, this second part is saying, let x represent the weekly sales that she is paid commission on. So this is the same as this one, but it's the weekly sales that she is paid commission. Sorry guys, hold on, my video just went out. So many technical issues. Okay, there we go. Hopefully we're still recording. Where was I? So we're writing a function to represent her commission. So basically 3% multiplied by the amount of sales over 1,500 will tell us how much money she's getting paid only on commission. So this part was only about commission, and that's 0.03 times x. So now this third part is we're writing a composite, when we put two things together, function. And it thankfully tells us g of f of x. So basically, we're going to input f into g. That's the one in the middle, right? And it represents the amount of money Priscilla earns on her commissions. So what we do is we're going to take our g of x, which is this guy, which is 0.03x, and we're going to input x minus 1,500. So we get this function right here. I distribute the 0.03 into each by multiplying, and I get 0.03x minus 45. This number times this number gives me 45. So this is what she would use to figure out her finances for her commission-based finances. All right. So this is another, kind of real-world scenario. This is talking about a resort hotel that charges 12.5% taxes. Additionally, they charge $25 as just like a resort fee, so it's kind of on top of everything, which isn't subject to the tax. It says the following function represents a situation. So thankfully, it gives us the functions, makes it a little bit easier. So we have f of a, which is 1.125a. Now that 1.125 is this guy right here. Now the reason that it's 1.125 is because you are paying 100% of, the cost of like the hotel, right? So on top of that, you're paying 12.5% in taxes. So, if a hotel costs, I don't know, let's say $200, we're going to add the 12.5% of this to get our total. So that's why it's 1.125. Now, g of b is b plus 25, and that's basically just saying the resort fee is 25 bucks. So this one doesn't really want us to solve anything. It's more just talking about the meaning behind all of this. So match the following to their description. So it wants us to describe A. A, if we notice, is right here and right here along this function. And that one represents the cost of the hotel room without sales tax or the resort fee. So it doesn't have anything to do with that $25, and it doesn't have anything to do with the tax. Now, B, which is right here and right here, and f of a, which is this entire function right here, they both mean the cost of the hotel room and the sales tax, but it does not include that $25. So that B is just separate, right? Now, when we finally get to g of b, this entire function right here, b plus 25, that's the cost of the hotel room with the tax and the resort fee. So it's this and this. Oh, and I missed this. So this wants us to actually combine the two functions. So basically, we're going to input f into g. So let's write this out. G is this guy right here. So I have b, and then I have plus 25, right? Now, if this is what, if b is our variable, and we're going to insert f, which is this whole thing right here, that's where this is going to go. So it's 1.125a plus 25. So because there's no multiplication, that would kind of be your answer. So it's g of f of a is equal to 1.125a plus 25. That's the two combined. And then the last little couple notes here, guys, is just kind of talking a little bit more about definitions. So this one is asking, what's the difference between combining functions and composing functions? So this is kind of an important thing because vocabulary with math sometimes can get tricky, but when you understand the vocab a little bit more, you're gonna understand the math more. So when we combine functions, that is when you perform some operations with the functions like addition, multiplication, subtraction, division. It's when we're actually, doing something like we did here. We combined them. Now, when we compose, that is when we take the output of one function that then becomes the input of another. So that's like taking, well, I'll get over it. I'll show an example in just a second. So a real world example of combining, which is where we, insert a function within a function. So an example of that is kind of like what we did a couple lessons ago in regards to profit. So, we could find a profit function by subtracting the cost function from the revenue. So if you remember, it kind of looked like this. The profit function can be found by subtracting the revenue by the cost, and it kind of looks like that. So that is a example of combining functions. Now, when we compose them, that's where you have like that's where you have functions within functions. So functions within functions. That's a good way to put that. So here it's just a matter of like, here's a function and we're going to add it to another. But here, this is where you put one within the other. And, a good example of that would be someone earns an hourly rate and then overtime. Just like we did in this example, when we're dealing with money that you earn at different rates, that's where a good example of that would be. So that's it, guys. Thanks for listening.